Welcome to the mysterious world of quantum physics. Today, we're exploring one of the most famous experiments in scientific history. Quantum mechanics often defies our everyday logic, suggesting that reality is far stranger than it appears to the naked eye. When we zoom in to the scale of atoms and subatomic particles, the rules of our classical world simply stop applying. The divide between how large objects move and how subatomic particles interact is the central mystery of quantum physics. In our world, things are predictable. If you throw a ball, you know exactly where it will land. We expected particles to follow similar rules. Imagine throwing marbles at a wall with two slits. You expect two neat piles of marbles to form behind the wall, right? But waves are different. When a wave passes through two slits, the crests and troughs overlap to create an interference pattern. Now, let's set up our experiment. We have an emitter firing tiny particles, like electrons, toward a screen with two narrow slits. We expect the electrons to act like marbles, but the results are going to shock us. Physicists predicted either two bands or an interference pattern. The reality turned out to be far more bizarre. The particles fired one by one created an interference pattern on the back screen. It was as if each particle was a wave. An interference pattern only occurs if a wave passes through both slits simultaneously, interfering with itself. How can a solid-seeming particle pass through both slits at once? It seems like they act like waves until they hit the detector. To solve this, scientists placed a detector at the slits to see which one the particle chose to go through. The moment we observe which slit the particle passes through, the mystery deepens even further. As soon as we watch, the interference pattern vanishes. The particles stop acting like waves and act like standard marbles. It's as if nature knows it's being watched. The act of measurement changes the outcome of the experiment entirely. This reveals the fundamental duality of our universe. Matter behaves as both a particle and a wave. This state of being in multiple possibilities at once is called superposition. It's the engine behind quantum computing. This experiment forces us to rethink reality itself. Thank you for joining me on this journey into the quantum realm. How does a single particle interfere with itself? It exists as a wave of probability, exploring all paths until it is measured. This shatters our classical intuition, proving that the world at its most fundamental level is governed by probability, not certainty. The Double Slit Experiment remains the cornerstone of modern physics, challenging us to embrace the bizarre and beautiful nature of the quantum world.